morning, students. I hope you all are fine. Today we are starting exercise 1.5, and you have done question number 1 of this exercise, in which you found the determinant of the matrices, right? Question number 2 asks you to find if the following matrices are singular or non-singular. So let's see, how do we check if a matrix is singular or non-singular, right? A matrix is singular when its determinant is equals to 0. Let's say I have a matrix A, right? 1, 2, 3, 4. Right? It will be singular if its determinant is equals to 0, right? It means that the determinant of A is equals to 0. So this is the condition that must be fulfilled for a matrix to be singular, right? And for a non-singular matrix, the determinant is not equals to 0. If the determinant is not equals to 0, then we say that the matrix is non-singular matrix. Alright. Now the second thing that we will learn in this lecture is the adjoint of a matrix. How do we find the adjoint of a matrix? Let's say I have a matrix A. Let's take the same matrix A. 1, 2, 3, 4. Now to find the adjoint of this matrix, firstly we will replace the entries of the first diagonals, right? So to find the adjoint of this matrix A, I'm gonna replace the you can say the position of these two entries of the first diagonal. This is our first diagonal here, right? So 4 will come at the place of 1 and 1 will come here, right? The second thing we do is we change the symbol of the entries of the second diagonal. This is our second diagonal, right? 3, 2. So I'm gonna change the symbol of these two entries. 3 is positive, it will become negative here. Again 2 is positive, it will become negative. Now let's find the adjoint of another matrix. Let's say I have a matrix B, which is equals to -2, 4, -1, and let's say here I have -6, right? Now let's find the adjoint of this matrix. As we know that firstly what we do, we change the position of these two entries. -1 will go here and -2 will be at the place of -1. So adjoint of B will be -1, -2. Now with the second diagonal, what we do, we change the symbols of these entries. Like 4 is positive, it will become negative here, and 6 was negative, so here we will have +6. So this is the adjoint of P. It's very simple, right? Now the next thing that you need to learn is the inverse of a matrix, right? So let's see, how do we find the inverse of a matrix? Right, let's say I have a matrix A. Okay, as we know that we denote the matrix by any alphabet, right? Capital alphabets. So the inverse of this matrix A will be denoted by, inverse of A will be denoted by A raised to the power -1. Okay, so now let's see, how do we find the inverse? To find the inverse, we have the formula A inverse is equals to adjoint of A divided by determinant of A. Okay, so here we have now you know that how do we find the adjoint of a matrix, as well as you know how to find the determinant of a matrix. So you will simply find adjoint and determinant and put their values in this expression to find the inverse of any matrix, right? This is the expression, or you can say formula, that you will use to find the inverse of any matrix. That's all we have for today.